The following function is a probability density function on the given interval. So we've got f of x is ax squared x minus 2 for values of x between 0 and 2, and it's 0 otherwise. We want to find the value of a. Well, one of the things we know is that if we graph this, whatever it looks like, the area underneath there must be equal to 1. So if we do the integral from 0 to 2 of ax squared x minus 2 dx and put that equal to 1, you can just simply solve that on the class pad. Now, I'm not going to do class pad for every single thing that we go through in this paper, but this one's worthwhile. So we're going to go Action, Advanced, Solve, and then we've got our integrals on Math 2. So we're going to go Integral, and we need to go from 0 to 2 of. Now what I'm going to do is put that in as y x squared bracket x minus 2 dx, and we need to put that equal to 1, and since I'm solving for y, you have to tell the calculator that, so I'm going to put an equals y, and there we get it. Y is negative 0.75, so that means for us a is negative 0.75. We now want to find the probability that x is greater than or equal to 1.2. So continuous, and therefore it's just an integral, and we're going to go from 1.2 to 2. We now know the a value, so negative 0.75, x squared x minus 2 dx, and we're just going to evaluate that, and it is 0.5248 to 4 decimal places. Then we want to find the median of the distribution. Now, the median is going to be some value here, m, such that the area here is 0.5 either side. So I'm going to set that up as the integral from 0 to m of negative 0.75 x squared x minus 2 dx is equal to 0.5, and we need to solve that. Again, we can use the CAS for that. I might be able to edit this one. Let's put the y up there and replace that with the negative 0.75, and then we want that to be 0.5. We're already telling it we're solving for y, and it's got to be a positive. Well, it's got to be positive, but it's got to be between 0 and 2, so it can't be that one. I could explain why. In fact, I will explain at the end why that one appears. So we've got the m is 1.2285. Yeah, the reason that one appears is that we know the area when you do all of that is 1, but the curve would continue on beyond that. And you know areas above and below cancel, so when you get to that other value, whichever 2 point whatever it was, the area down here would cancel with half of the area above, and so it would be equal to 0.5 again. But we know that we need the value that's between 0 and 2, and that's what we took.